VLANs can also be used as security measure by controlling which hosts can communicate. In general, VLANs make it easier to design a network to support the goals of an organization. VLAN trunks are used to span VLANs across multiple devices. Trunks allow the traffic from multiple VLANs to travel over a single link, while keeping the VLAN identification and segmentation intact. You will create VLANs on both switches in the topology, assign VLANs to switch access ports, and verify that VLANs are working as expected. You will then create a VLAN trunk between the two switches to allow hosts in the same VLAN to communicate through the trunk, regardless of which switch to which the host is attached. Build the network and configure basic device settings. Build the network shown in the topology. Click and drag both switch S1 and S2 to the rack. Okay, this is switch S1, S2. 2960 switches. Okay, drag S1 and drag S2. Click and drag both PCA and PCB to the table. Okay, you need PCB and PCA. And drag to the table. This is PCA and PCB. Provide network connectivity by connecting copper straight-through cables as shown in the topology. Okay, between S1 and S2, fast Ethernet 1 and fast Ethernet 1. Use this cable, copper straight-through, fast Ethernet 1, fast Ethernet 1, to connect PCA from switch 1, fast Ethernet 6. From switch 1, fast Ethernet 6 to PCA. And from fast Ethernet 18 on switch 2 to PCB. And from fast Ethernet 18 on switch 2 to PCB. Okay, very good. Connect console cable from device PCA to S1. Okay, use this blue cable from PCA to S1 is the console cable. So the console cable is this light blue cable console to connect from RS232 on PCA to console on S1. But the console on S1 is right-click, inspect rear, and this is the console. Now you have this connection from PCA RS232 to S1 console using the console cable or rollover cable. And from PCB to S2, use the another console, this, and connect the RS232 on PCB, right-click, inspect rear to console, and now you have this connection, PCB RS232 S2 console. Configure basic settings for each switch. From Desktop tab on each PC, use Terminal to console into each switch and enable privileged exec mode. Okay, and from PCA, access the console of S1. Click on Turn on the PC. Turn on PCB. Uh, switches are power on because they are connected to the power distribution device, and this connection is enough. And click on PCA Desktop Terminal to access the console of the device. Okay, now you are on the console of S1. Enter. You are on. This is the prompt for S1. Enable privilege exec mode. Enable. Enter. Enter configuration mode. Configure terminal. Assign device name. Okay, in this case the name is S1. Like addressing table shows the name or topology S1. Hostname S1. Class is the privilege exec encrypted password. Enable secret class. Cisco is the console password and enable login. Okay, line console 0 password Cisco and enable login. Okay, enable login. Login. Exit. Assign Cisco as the VTY password and enable login. Okay, line VTY. Virtual lines from 0 to 15. All the virtual lines from 0 to 15, you have 16 lines. Password Cisco and enable login. Then exit. You are on global configuration mode. Encrypt the plain text passwords. Use service password dash encryption. Create a banner that warns anyone accessing the device that unauthorized access is prohibited. Banner, message of the day, and unauthorized access is prohibited. Unauthorized access is prohibited. Configure IP address listed in the addressing table for VLAN 1 on the switch. Okay, this is VLAN 1, the switch S1 IP address, not default gateway. Interface VLAN 1, IP address 192.168.111, subnet mask, no, shut down. Shut down all interfaces that will not be in use. Okay, used interfaces on S1 are Fast Ethernet 1 and Fast Ethernet 6. Fast Ethernet 1 and Fast Ethernet 6 in use. So, okay, exit from VLAN 1 and interface range from Fast Ethernet 2 to 5, and Fast Ethernet 7 to 24 and gigabit 1 and 2. Okay, 1 is in use, so select the range from 2 to 5. 6 is in use, so select from 7 to 24, and don't forget gigabit 1 and 2, 01 and 02. Enter. Shut down. Okay, exit. Set the clock on each switch. exit. Do this on privilege exit mode. Clock set question mark the current time, question mark the date of the month, September, and the year 2021. Okay, very good. Save the running configuration to the startup configuration. Copy running -config to startup-config. Enter. Okay, and don't forget to configure switch 2. Start from step 2. Switch 2 is connected to PCB. So click on PCB, desktop, terminal, okay. Enter, and all this process, okay. Privilege exit mode, enable configuration mode, configure terminal, device name, host name S2, class privilege exit encrypted password, enable secret class, Cisco console password, line console 0 password Cisco login, and Cisco BTY password, line BTY 0 to 15, password Cisco login, exit, encrypt the plain text passwords, service password encryption. The banner message of the day, unauthorized access is prohibited. IP address, use the addressing table for switch S2 VLAN 1. Okay, interface VLAN 1, IP address 192.168.112. Okay, no shutdown, exit. Shut down all interfaces not in use. Okay, on S2, interfaces in use are fast Ethernet 1 and 18. So use the following range, interface range. 1 in use, so select from 2 to 17. 18 in use, so select from 19 to 24. And don't forget gigabit 01 and 02. Shut down. Exit. Okay, very nice. Set the clock on each switch. Okay, and so do this on privilege exit mode. Clock set the hour, minute, and second. Hour, minute, second. Day 29 September 2021. Enter. Very good. Save the running configuration. Copy running config to startup config. Enter. Okay, very nice. Configure PC hosts. From desktop tab on each PC, click IP configuration. Enter the addressing information as displayed in the addressing table. Okay, look at the configuration of PCA, IP address, subnet mask, and default gateway. This is for PCA. Click on PCA and close terminal IP configuration. 192.168.10.3, subnet mask, and default gateway 10.1. And click on PCB, close the terminal IP configuration. 192.168.10.4 and 192.168.10.1. Okay, this is for PCB. 192.168.10.4 subnet mask and default gateway 192.168.10.1. Okay, this is very good. Test connectivity. Can PCA ping PCB? Great, go to PCA. Command prompt ping PCB. What is the IP address of PCB? 192.168.10.4. Success. So the answer is yes. PCA ping S1. Okay, from PCA ping S1. This is the IP address of S1. 192.168.1.11. Okay, the answer is no. Ping fails. Can PCB ping S2? Go to PCB. Command prompt ping S2. This IP address 192.168.1.12. Okay, the answer is no. Ping fails. And can S1 ping S2? Okay, go to S1. So access the console. Remember, PCA is connected to the console of S1. Click on PCA and go to terminal to access the console of S1. Enter privilege exec mode ping S2. This is the IP address of S2. 192.168.1.12. Okay, success. Repeat. All success. The answer is yes. If you answered no to any of the above questions, why were the pings unsuccessful? Pings were unsuccessful when trying to ping a device on a different subnet. For those pings to be successful, a default gateway must exist to route traffic from one subnet to another. Okay, look at this. According the IP address and subnet mask, switches are on different subnet of PCs. Okay. Create VLANs and assign switch ports. You will create management, operations, parking lot, and native VLANs on both switches. You will then assign the VLANs to the appropriate interface. The show VLAN command is used to verify your configuration settings. Create VLANs on the switches. Okay, on S1, create the VLANs. Okay, S1 is connected on PCA. Okay, this is the console. Configure terminal, VLAN 10. Name operations, case sensitive, be careful. VLAN 20. Name parking lot underscore lot. Okay, parking underscore lot, case sensitive, VLAN 99. Name management, VLAN 1000. Name native, and create the same VLANs on S2. So go to PCB, click on PCB, and go to terminal. Okay, Enter. Remember the password for the console was Cisco. Enter. Enable. The password for enable is class. Configure terminal. VLAN 10. VLAN 10 name operations. VLAN 20 name are king underscore lot. Enter. VLAN 99 name management. VLAN 1000 name native. And show VLAN brief to view the list of VLANs on S1. Okay, click on PCA. This is the console of S1. S1 and show VLAN brief. Now you can see 10, 20, 99, and 1000. The 4 VLANs created. What is the default VLAN? The default VLAN is VLAN number 1. What ports are assigned to the default VLAN? All ports are assigned to the default VLAN from 1 to 24 and from gigabit 01 to gigabit 02. Assign VLANs to the correct switch interfaces. Assign VLANs to interfaces as one. Okay, to operation VLAN. Use these commands: VLAN 10, fast Ethernet 6. Look at the topology: PCA connected to fast Ethernet 6 on S1 and will be on VLAN 10. Go to PCA. This is the console for the switch. Enter. The password for the switch, the console password is Cisco. Enable, and this password is class. Configure terminal. Interface for Ethernet 6. Switch port mode access. Switch port access. VLAN 10. Operations. From VLAN 1, remove the management IP address and configure it on VLAN 99. Okay, access VLAN 1, the virtual interface VLAN 1. Remove the IP address and on interface VLAN 99, assign the IP address. Interface VLAN 1, no IP address. Shut down if you want. Interface VLAN 99, IP address 192.168.1.11.255.255.255.0. No shutdown command is not necessary because VLAN 99 automatically changed state to up. And if you have this message translating the main server, Control-Shift-6. Control-Shift-6. Okay, and show VLAN brief command and verify the VLANs are assigned to the correct interfaces. Show VLAN brief. Fast Ethernet 6 to operations, VLAN 10. Show IP interface brief. Show IP interface brief. Okay, and for Fast Ethernet 6, status up, protocol up. Fast Ethernet 1, status up, protocol up. VLAN 1 down. VLAN 99 IP address, status up, protocol down. What is the status of VLAN 99? Explain. The status of VLAN 99. The status of VLAN 99 is up and protocol is down. The status is up because the VLAN exists in the database but the protocol is down because the VLAN has not been assigned to an active port yet. Assign PCB to operations VLAN on S2. Okay, PCB is connected to FacetNet 18 and add to VLAN 10, operations VLAN. Okay, and click on PCB to configure switch S2. Enter. Cisco is the console password. Enable. Class the enable password. Configure terminal. Interface FacetNet 18. Switch port mode access. Switch port access. VLAN 10. Okay, and from VLAN 1, remove the management IP address and configure it on VLAN 99. Okay, and for S2, change the management VLAN from 1 to 99. Interface VLAN 1, no IP address, shutdown. Interface VLAN 99, IP address. According the addressing table 182.168.112, subnet mask. Okay, no shutdown is not necessary because interface VLAN 99 automatically changes state to up. And show VLAN brief. Show VLAN brief. 18 to VLAN 10. Is S1 able to ping S2? Okay, go to PCA to access S1 console. And from S1, try to ping S2, 192.168.112. Is S1 able to ping S2? No. The IP addresses for the switches now reside in VLAN 99. VLAN 99 traffic will not be sent over interface FacetNet 1. This is FacetNet 1, the connection between S1 and S2. Is PCA able to ping PCB? Okay, go to PCA, close terminal, command prompt, and try to ping. PCB is 10.4. 10.4. Okay, ping failed. Okay, is PCA able to ping PCB? No, interface FacetNet 1 is not assigned to VLAN 10. So VLAN 10 traffic will not be sent over it. Maintain VLAN port assignments and the VLAN database. You will change port VLAN assignments and remove VLANs from the VLAN database. Assign VLAN to multiple interfaces. On S1, assign interfaces 11 to 24 to VLAN 99. Okay, go to PCA, close command prompt, open terminal, okay. Configure terminal, interface range, fast Ethernet 11 to 24, switch port mode access, switch port access, VLAN 99. And remember, these ports are not in use, and show VLAN brief, show VLAN brief. Now you can see VLAN 99, you have from 11 to 24. Reassign fast Ethernet 11 and 21 to VLAN 10. Configure terminal, fast Ethernet 11, interface range, fast Ethernet 11. It's not a range, they are only two interfaces, comma, fast Ethernet 21. Okay, for the range, use the dash. In this case, it's not range, these are only two interfaces, 11 and 21. Okay, switch port, access VLAN 10. And verify, show VLAN brief. Okay, 11 and 21 on VLAN 10 operations. Remove a VLAN assignment from an interface. No switch port access VLAN command to remove the VLAN 99 assignment to fast Ethernet 24. Use these commands on S1, so access to PCA S1. Configure terminal, interface, fast Ethernet 24. No switch port access VLAN. Enter and verify. Show VLAN brief. Okay, and before to apply the command, fast Ethernet 24 was on VLAN 99 management, and after apply these commands, 24 will go to VLAN 1, the default VLAN. Which VLAN is fast Ethernet 24 now associated with? VLAN 1, the default VLAN. Remove a VLAN ID from the VLAN database. Add VLAN 30 to the interface 24 without using the global VLAN command. Okay, configure terminal. And remember, VLAN 30 does not exist. Interface fast Ethernet 24. Switch port, access VLAN 30. Enter. Access VLAN does not exist. Creating VLAN 30. The current switch technology no longer requires that the VLAN command be issued to add a VLAN to the database. By assigning an unknown VLAN to a port, the VLAN will be created and added to the VLAN database. Verify that the new VLAN is displayed in the VLAN table. Okay, and show VLAN brief. Now VLAN 30 and uses this default name. And what is the default name of VLAN 30? VLAN 0030. Use the no VLAN 30 command to remove VLAN 30 from the VLAN database. Okay, global configuration mode, configure terminal, no VLAN 30. Enter, and show VLAN brief. Show VLAN brief. And no VLAN 30, FastEthernet 24 was assigned to VLAN 30. Deleting VLAN 30 from the VLAN database. Why is FastEthernet 24 no longer displayed in the output of the show VLAN brief command? What VLAN is port FastEthernet 24 now assigned to? What happens to the traffic destined to the host that is attached to FastEthernet 24? Okay, no FastEthernet 24. When you delete a VLAN, any ports assigned to that VLAN become inactive. Port FastEthernet 24 is still associated to VLAN 30, but is not longer shown in the output. VLAN 30 is now inactive because it does not exist in the VLAN database. Any port associated with VLAN 30 will not transfer any traffic. On interface 24, issue no switch port access VLAN command. Okay, configure terminal interface FastEthernet 24. No switch port access VLAN. Enter and verify show VLAN brief. And now 24 is in VLAN 1. Show VLAN brief, and to which VLAN is FastEthernet 24 assigned? The default VLAN 1. Before removing a VLAN from the database, it is recommended that you reassign all the ports assigned to that VLAN. Why should you reassign a port to another VLAN before removing the VLAN from the VLAN database? The interfaces assigned to a VLAN that is removed from the VLAN database become inactive and are unavailable for use until they are reassigned to another VLAN. This can be a tricky thing to troubleshoot, as truncate interfaces do not show up in the port list as well. Configure an AO2.1Q trunk between the switches. You will configure interface FastEthernet 1 to use dynamic trunking protocol DTP to allow it to negotiate the trunk mode. After this has been accomplished and verified, you will disable DTP on interface FastEthernet 1 and manually configure it as a trunk. Use DTP to initiate trunking on FastEthernet 1. The default DTP mode of a 2960 switch port is dynamic auto. This allows the interface to convert the link to a trunk if the neighboring interface is set to trunk or dynamic desirable mode. On S1, set FastEthernet 1 to negotiate trunk mode. On S1, interface FastEthernet 1 and use switch port mode dynamic desirable. On S1, configure terminal FastEthernet 1 interface FastEthernet 1. Okay, on this side of the trunk, on the side of S1, enter switch port mode dynamic desirable. Enter. Okay. Line protocol of interface VLAN 99 changed state to up. You should also receive link status messages on S2. Okay, go to S2, click on PCB. Now you can see line protocol on interface VLAN 99 changed state to up. On S1 and S2, issue the show VLAN brief command. Interface FastEthernet 1 is no longer assigned to VLAN 1. Truncate interfaces are not listed in the VLAN table. We click on PCA and show VLAN brief. No FastEthernet 1. Before, Fast Ethernet 1 is on VLAN 1, and now Fast Ethernet 1 is trunk and is not here. The same way on S2. Show interfaces trunk. Showing interfaces trunk. Now you can see port Fast Ethernet 1. Notice that the mode on S1 is set to desirable. Okay, the mode is desirable because you configured this with switch port mode dynamic desirable. Fast Ethernet 1, and the mode is desirable. And go to S2, enter Cisco console password, enable class the enable password, and show interfaces trunk. In this case, Fast Ethernet 1, the mode is auto. Okay, the mode is auto because the default configuration on Fast Ethernet 1 is dynamic auto. By default, all VLANs are allowed on a trunk. The switchport trunk command allows you to control what VLANs have access to the trunk. For this activity, keep the default settings. This allows all VLANs to traverse Fast Ethernet 1. Verify that VLAN traffic is traveling over trunk interface Fast Ethernet 1. Can S1 ping S2? Okay, go to PCA, go to console of S1, ping 192.168.112. Remember, 112 is S2. Enter. Success, repeat, success. PCA, ping PCB, close terminal, open command prompt, ping PCB, PCB is 10.4, 10.4, enter, success. Can PCA ping S1? Here, ping S1. S1 is 1.11. Okay. Can PCA ping S1? No. Can PCB ping S2? Click on PCB. Then close the terminal, open command prompt, and try to ping S2. Remember, S2 is 112. Okay. Can PCB ping S2? No. If you answered no to any of the above questions, explain below. The switches are in VLAN 99, and the PCs are in VLAN 10. Therefore, the pings between VLANs were unsuccessful. Manually configure trunk interface Fast Ethernet 1. The switchport mode trunk command is used to manually configure a port as a trunk. This command should be issued on both ends of the link. On interface Fast Ethernet 1, change the switchport mode to force trunking. Make sure to do this on both switches. Okay, this command on both switches. Go to terminal. Okay, configure terminal interface Fast Ethernet 1. Switch port mode trunk. Enter. Exit and go to PCB. Close command prompt, open terminal. Okay, you are on S2. Configure terminal. interface facet node 1, switch port mode trunk, enter, exit. Show interfaces trunk to verify. Notice that the mode changed from desirable to on. Okay, go to PCA and show interfaces trunk. The mode is on, manually configured to trunk. Go to PCB and show interfaces trunk, mode on, manually configured to trunk. Modify the trunk configuration on both switches by changing the native VLAN from VLAN 1 to VLAN 1000. Okay, by default, this trunk is using VLAN native 1. Okay, the same way on the other side on S2. On S2, the native VLAN is 1. And change this to 1000. Go to PCA, configure terminal, interface facet node 1, switch port, trunk, space, native VLAN 1000. Okay, and go to the another side. You can see this message, inconsistent local VLAN. Okay, the native VLAN on facet node 1 on S1 is 1000. The native VLAN on facet node 1 on S2 is 1. So change to, okay, configure terminal, facet node 1, switch port, trunk, native VLAN 1000. Okay, and now you can see this message, port consistency restored. Show interfaces trunk, enter, show interfaces trunk, native VLAN 1000. The another side, enter, and show interfaces trunk, native VLAN 1000. Why may you want to manually configure an interface to trunk mode instead of using DTP, Dynamic Trunking Protocol? Not all equipment uses DTP, Dynamic Trunking Protocol. DTP is Cisco proprietary, and using the switch port mode trunk command ensures that the port will become a trunk no matter what type of equipment is connected to the other end of the link. Why may you want to change the native VLAN on a trunk? Using VLAN 1, the default VLAN with the native VLAN is a security risk. All the different control protocols that are exchanged between switches are exchanged via the native VLAN 1 contagion. And that information could be exposed if the default settings are used on ports that users connect to. What is needed to allow hosts on VLAN 10 to communicate to hosts on VLAN 99? To allow inter-VLAN routing requires a layer 3 device like a layer 3 switch or a router, and this is necessary to route traffic between VLANs. What are some primary benefits that an organization can receive through effective use of VLANs? VLAN benefits include better security, cost savings, efficient use of bandwidth and uplinks, higher performance, smaller broadcast domains, broadcast storm mitigation, improved ID staff efficiency, simpler project and application management. Completion 100%. Thank you very much.